Hello everyone, welcome back. So in this video, we are going to understand the problem number 865, a smallest subtree with all the deepest node. So very first, the question is saying that we have given the root of binary tree. The depth of each node is the shortest distance to the root. So we have to return the smallest subtree such that all contains the all the deepest nodes in the original tree, right? So node is called the deepest if it has the largest depth possible among any node in the entire tree. So the subtree of the node is a tree consisting of the node plus the set of the descendant node. So as you can see here, look like this, right? So here, these subtree 2, 7, and 4 are the deepest subtree, right? As you can see. So we'll discuss this problem in details and how we'll solve this problem. So we'll see. Okay, so let's continue and try to understand. So let's try to understand the problem. Okay, very first, the problem is Leetcode 865, guys, right? And it is saying the we have to find the smallest subtree, right, with all the deepest nodes, right? So we'll try to understand. Very first, you see what we have given. Okay, so we have given a binary tree. So binary tree contains a no, let's suppose if this is a root node, right? It contains maximum two nodes like this and this. So a node that contains two nodes or less than two nodes is called binary node, right? And there are some more conditions are there, that is in the depth. So in the short, we can say like this, and these are called children. Okay, so this is what is the binary tree. I hope you understand. Now, what the question is saying that the binary tree we have given with some of the properties. What are those properties are? Some nodes are deeper than others. It is saying we have given binary trees and some nodes are deeper than others, we can say, right? It means what? Some nodes we have given deeper than the others means if we'll compare the some nodes, so it will be deeper than others, okay, for the childs. Then we can say the deeper nodes are the furthest uh, farthest, or we can say the deeper nodes are the one deeper nodes are the one or ones farthest, right? Farthest from the root, we can say. Okay. And what is our goal? Our goal or task. So we have to find the smallest subtree, right? That contains all of those deepest nodes, right? Can we say that? So we should must return, we should must return what the root of that subtree. Right, guys? What is the question saying? Question saying that Leetcode 865, a smallest subtree with all the deepest node. What we have given? We have given a binary tree where binary tree says that there is a root, it should have one children or more than one children. Okay, either one children or more than one children. Children one, children two. Okay, so if this root, there can be maximum two children. Some nodes are deeper than others. How? This is the level. If we compare this node with this node, is different, right? Because this is deeper than it. What is the depth of this? Depth is 1 or 0. Depth is, if we call 0, this is 1. If this is the depth is 1, it is 2, right? We can say that. The deeper nodes are the one who is farthest from the root. So this root should be always greater than this root, right? So if the level is 1, so this level is what? 0. If this level is 2, if this level is 1, like that we can say that. What is our task, right? Our task, we have to find the smallest subtree that contains all the deepest node, right? And we will return the root of the subtree. This is what we have to do, guys, right? So, so think of it as a problem, right? We can say, uh, what is the common ancestor, right? What is the lowest, yeah, I forget the name, lowest common ancestor, right? Ancestor, like this we can say. In short, this is called LCA. So, what is the LCA of all the deepest nodes? Understand? So, we have to find the lowest common ancestor or LCA of the deepest node. So, this is very important to understand, guys. Okay? Okay, guys? Now, let's go by understanding an example so we can understand the concept. Okay, what is the concept is saying? Let's see. Very first, we know that we have to find the what do you call the deepest node. So we should identify the deepest node and then we'll find the answer. Okay, so think of it like we have given a tree. So I'll say the tree is like we have given 3, then we have is 5, and this we have given is 1, and 1, let's suppose we'll take 1 8 we can take here. Here we can take 5, then there is a 6, then we have is 2, and from the 2 we can go to 2 children, we can have 7 and 4. Now very first I will tell that what we need to do, we should identify what do you call the deepest node, right? So very first think that what is the level, right? If I'll say this level, this level, this level, and this level, how many levels are there, guys? So you can say this level is, we can say L1, L2, L3, and L4, right? It means the very first level is L1, then we have L2. We are in L1, there is only one element, that is root element. In L2 level, we have 5, 4, we have, and L3 level, we have 5, 6, and 8, and then we have this level, right? At L4. So if I want to find the deepest level, what is the deepest level? Deepest level is 4. And what is the nodes value we have here? Is 7 and 4, right? Now we need to find the smallest subtree that contains 7 and 4, right? So the 7 and 4 is the deepest node, and if you want to find the lowest node that contains this 7 and 4 subtree is what? This one, right? So node 2 is the correct answer. Okay, so we'll return node 2. I hope you understand what we need to do, guys. Very first, step 1, always identify identify the deepest node, or nodes we can say. So we'll say, okay, the deepest node level is, right, node level we can say is what? Level 4, and nodes at that levels are 7 and 4, right? In step 2, right, we can say find the smallest subtree that contains or containing both 7 and 4. So the lowest node that has 7 and 4 in the subtree is what? Is node 2. And so our answer is node 2. Understand, guys? What I said, we have to identify the deepest node, and those deepest node are 7, 4, and its level is level 4, and the nodes at that level is 7 and 4. So we have to find the deepest, smallest subtree containing both 7 and 4, and that is, this is the smallest one. So we'll say, okay, lowest node that contains 7, 4 is the subtree nodes is 2, and this is our answer. Understand? Now think that what we trying to achieve here, right? So as I said, 7 and 4, these are the deepest node, right? And the path from root to the both node, right? Root to the both node, correct? These are the paths, right? So first common node on both path is this. So that node form the smallest subtree. Are you understanding? I said the path from root to both node. What is the common? Common is this one. So this node forms the smallest subtree. Okay. And that is why this becomes our answer. Correct? So what you can do is try to do by the recursion approach, where you can go from bottom to upside. Okay, so the recursive function should return the depth of the subtree, what is the depth of this subtree, and the candidate nodes for the answer. Okay, so in the traversal you can use the a post order, right? So let's suppose if you are going with the 7, right, you should think that this is a level 1, then you will go to the 4, still the depth is 1, right? So you start from the node 7 and 4, right? Very first node 7, then you'll come to here. Once these two are completed, you will go to the root, right? In the post order, first left, then right, and then node, what do you call, the root node we used to go, right? So you will complete that this depth, then you will come to this level, then this level, and then this level. Like that, you will come. Okay. So if I want to uh, if let me go here. Yes, take it here. Let's suppose the very first node is 7, and what is the depth? Depth is equal to 1. When we traverse, right? So I'll say traversal order. What will be our traversal order? So we will use a post order, post order traversal order. Okay. Very first 7 will come. The depth is 1. Then we'll take, okay, take the value 4, node 4. What is the depth? Depth is still is 1. Then we'll go to here. Once this is done, we'll go to this level, right? So now we will go to the node 2. What is the depth? We'll say, okay, the left depth is 1, right? Left depth is equal to 1, right? Depth is equal to 1, right? So if left depth and right depth is 1, means then we will choose the node 2, right? So we have chosen the node 2, right? Once we did to node 2, right? Now we have to go to our node 6. Node 6, here depth is equal to, let's suppose, is 1, right? Because still the depth is remaining same. Okay. Then we'll go to the node 5, right? Here left is equal to 1, right is equal to 2, right? So we'll say, okay, because its depth, this level is 1. See, for this level, depth is equal to 1. Here depth is equal to 1. So at here, the depth, the node will become, because this is 1, this is 1, so depth is become here is 2. Here depth will become is what? Is 1, right? Because it traverses, right? It has to choose. When the left is here and the right is here, it means its depth become what? Is 2. Then we reach to the 5. Okay, so we'll say, okay, node 5 will reach here, and we'll say, okay, the depth should be become what? The left depth is equal to how much? 1. And the right depth is equal to how much? Is 2. So it should propagate to how much? Is 2, right? So we'll say, okay, its depth is equal to 2 now. How guys? So this depth is 1, this depth is equal to for this node, right? So what should be the depth now? It should be 2 now. Okay. Similarly, we'll go to the node 8 now. So 8 depth is equal to 1, and its other level, 1 depth level equal to how much? How much? 2, right? And this is 2 and 2. So its depth is become what? Is 3. Understanding? So like this, we have to propagate, right? And we know that, okay, its depth, what is the depth of the 3, right? So we can, because the left depth is equal to 2, yes, 2, and this become how much? This is 2, right? Yeah, correct. This is the 2. Okay, so we'll say, okay, we'll say the depth for this node is equal to left, let's suppose, gives you the depth 2, and here 2, so it will give to 2. Okay, finally, so like this we will propagates and we'll try to find. So how we are going to find the depth? Basically, if you want to understand the rule, right, the key rule is if the left depth, or LD can say, is equal to a right depth, so we can say current node is the answer, right? Else we have to propagate deeper sides node. I hope you are understanding. Okay, and that is why we found that our answer. So this problem is not about storing the path, guys. It is about comparing the depth, bottom up recursion we can say, and so we'll choose the meeting point of the deepest path that we have seen, right? Like this point we are saying, right? Never think about that. This problem is about the storing the path, right? No, we only compare the depth, right? And once you will compare the depth, right, approach is bottom up. Make sure that you are using bottom up recursions. So only we need to find the choosing points of the deepest node, right, that we talk about. Okay, so you can think of if both the left subtree and the right subtree are equally deep, so this node is the root of the smallest subtree, right? So let's go to the code and try to understand how to implement this type of problem. Okay, so yeah.
Hello everyone. So very first that we are going to write this code, right? So very first we have is to return the DFS root node, right? So from the DFS root, we'll have to do dot node and we'll try to understand how it will work, right? So very first, if you see, we are returning the result, right? So we need to create a node that is called the result that contains our result data. So if you see, there is a depth and the sorry node and the depth is there. So each node and depth we want in the result set, right? And to return the node, right, what you need to do, you just need to do dot node. So you will get this node value. I hope you understand, right? What I'm saying that this method, right, it will return the result. So you have to define the result node, okay, where this class contains node and depth. So it means to return the result, we need to do node dot, right, this node. I hope you understand. Okay, let's try to understand. The very first we have given is root node. So we'll create a DFS function because this is a recursive and in the depth wise. So we'll use the DFS and we'll create the recursive function. So recursive function is DFS where we'll use the same root node. So we'll check if root node is null, return the result as a null and its depth is 0. Means there is no root node, there is no node. Otherwise, go to the left and the right and find the result from the left side and the right side using the post traversal where you will have the node information and the depth, correct? Now we'll check if both sides have the same depth, means current node is the answer, right? So left depth is equal to the right depth. So we'll do what? We'll return the root and the left depth plus 1. What is the left depth we have? That left no depth plus 1, we can say that. So it will come that answer. Now we have to check if it is greater than the left depth is greater than right depth. It means left depth we have to increase. Okay, if left depth is smaller, it means right depth plus 1 we have to do, correct? But answer we will get only these three things we have to understand. Okay, and we need to create one more class that is called node, result node, we can say, where it will contain the node and depth, and that is why we are creating each time new result, right? I hope you understand. In case if you need any help, you can write me in the comment box, and for any uh, structured learning if you want to do in the proper way of my guidance, you can join our online classes, and for that you can inquiry through our WhatsApp channel. So that's all I have in this video, guys. See you tomorrow. Bye.
Thank you guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.